Hi everyone. Last time we were looking at side postulate. So if three sides of a triangle are congruent to its corresponding sides of another triangle, then those two triangles are congruent. For example, if you look at those three sides and in the triangle A and look at this triangle B, all those three sides, the corresponding sides, like if it's 4, 4, 6, 6, and 3, 3, if they are equal, then if you take this triangle and put on top of it, it will fit on top of it exactly or congruent. So this is what we learned last time. Also, we were looking at SAS postulate, which is side angle side postulate. If two sides and the included angle, make sure the included angle is very important. Those two sides make the included angle, all right, of one triangle are congruent to the corresponding parts of another triangle. So you take another triangle's two sides, which are equal to the first one, and then those two sides are making the included angle for the other triangle, then those two triangles also congruent. For example, this is included angle. Look at this. These two sides and those two sides making the angle, that's called included angle. Okay? The angle between two sides that we were talking about. All right? So look at these two triangles. Corresponding side, these two sides are congruent, plus those two sides making an angle, those angles also congruent, then these two triangles are congruent by side angle side postulate. So you should already know two of the postulate for triangle congruence. Now we are going to look at angle side angle postulate. What is it? It's pretty much the same thing, side angle side. Like included angle, in here it's vice versa, like we have two angles and those two angles, in between those two angles you're going to see a side. That's what we call angle side angle. If two angles and the included side of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So if you take two triangles and from one triangle's two angles and the included sides are congruent to the corresponding parts of another triangle, then those two triangles are congruent. For example, you have two angles and the included side. So if you look at those angles, in between those angles, there's a side. In here, the same way. And then these two triangles are congruent. All right. So now you know the third one. This is the fourth one, angle side theorem. In this case, we don't need to worry about included angle or included side. If two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the triangles are congruent. So if you look at these two triangles, it doesn't matter. Even if you have included side, it's congruent, it's good. Even if you don't have it, if you have two angles are congruent in two triangles plus non-included side, but it has to be corresponding. See, this side comes with this angle, which is 1 bar over here. Same here, this angle and this side. Then these two triangles are congruent. All right. So now you know 4 of them. 4 of the postulate. So you will see some question in the attachment, and also I added a video in there. So please watch it. And then I gave you 2 questions. It's a proof. You don't need to do entire proof. Only thing you need to do just to fill up the reasons that you need to fill up. I already gave you the statements, so you're just going to put the reason why the sites are congruent, if there are any specific reason. If I gave that, or if you can prove by what you learned previously in a previous math unit, and do it, and please submit. Thank you.